All right, infinite sequence. As you see here, I got key things that tend to get overlooked. It's a function whose domain is a set of positive integers. So you can't plug in any negative numbers. You can't plug in zero. So it starts with 1, 2, 3, on up. Okay, the function values are written as A1, A2, A3 are called the terms of the sequence. The nth term, this got jacked up somehow. The nth term, A sub n, is called the general term of the sequence. And it's like the formula, okay, to determine all the others. But remember, you only plug in, starting with n equals 1, n equals 2, n equals 3. Okay. All right, write the first 6 terms of each sequence. This is where that n equals 1 comes. The first number you can plug in is 1. The second number you plug in is 2, all the way through. Now you can list an infinite number. We just want the first 6. Okay, so right here I got 1, 2, 3, 4, 5, 6. And for the first term, let n equal 1, then n equals 2, n equals 3, n equals 4, n equals 5, n equals 6. Okay, all right, well, when I plug in 1, what do I get? 2 minus 1 is 1. Plug in 2, I get 3. Plug in 3, I get 5. Now, more often than not every time, but you're going to find a pattern, and you can kind of just continue the pattern. But it just makes sure it matches up when you do plug in the numbers. So I got 1, 3, 5, 7, 9, and 11. Okay, 1, 3, 5, 7, 9, and 11 for those. All right, that second one there. Not exactly the same format, but we got to follow the same rules. Plug in n equals 1, plug in n equals 2, all the way up to 6. Let's see what we get for this case here. You're going to have, I want the first 6 terms. 1, 2, 3, 4, 5, 6. All right, so for n equals 1, you got negative 1 to the first power times 2 to the negative 1. Negative 1 to the first is 2, or excuse me, is negative 1. 2 to the negative 1 becomes 2 to the first. So in the end, looks like I get negative 1/2. Okay. Where's the ball gun?
It codes for Perry.
Okay.
There's a girl's name.
Got it.
Roll them out any way you want.
Okay.
You can get 10 console codes in that promo.
Gotcha.
For visitor time.
Okay. Yeah.
One word.
All right. Thank you.
Yes, sir.
We good? All right. So plug in n equals 2. Ryan, what'd you get for that?
I didn't do it.
What? Negative 1 to the second power times 2 to the negative second. Negative 1 squared becomes just a 1. And then over 2 squared. So it looks like I got 1/4. We agree? All right. Go ahead and plug in 3, plug in 4, and see what you get. Oh, you going to decimal on me?
You want any fraction?
Yeah, it looks all nice. That's a sign of a higher intelligence.
That's
I know.
That's why I use decimals.
All right, Cole DeLuca, what'd you get for n equals 3?
I got negative 1/8.
Okay, negative 1/8. I agree with that. And then I get 1/16. Then I get negative 1/32. And then I get 1/64. Okay, for those. All right, this is a common occurrence here. If you want them to alternate between signs, negative, positive, negative, positive, this is where this negative 1 to the n power comes into play. Okay, that will alternate the signs, because if it's an even power, a negative number to an even power comes back positive, and a negative number to an odd power will come back negative. Okay, so whenever you see that, that means there's usually a -1 to a power involved for those. All right, so this is given the general term, come up with the other terms. And you always start with n equals 1. Okay, now going the opposite way. Write a general term, or basically think of it as a formula. Write a formula for each sequence. Assume, and this goes back to that definition that we're starting with the positive integers, n equals 1. So that means when I plug in 1, I get back 4 for this case. When I plug in 2, I get back 7. When I plug in 3, I get back 10. And when I plug in 4, I get back 13. Has to work for all of them. So what's our general term, A sub n? Well, you could just say n plus 3. Because if I plug in 1, 1 plus 3 is 4. But does that work for the second one? No, because then 2 plus 3 is 5. So it doesn't work for the second one, works for the first one. Anybody have it? What do you got, Cooper?
A to the n equals 4 plus 3 quantity n minus 1.
Holy cow.
Is that overcomplicated?
Yeah, it's overcomplicated. What do you got, Josh?
3n plus 1.
Thank you. 3n plus 1. Now take a look. Plug in 1, do you get back 4? Plug in 2, do you get back 7? Plug in 3 to get back 10, and plug in 4 to get back 13. Yeah. So 3n plus 1. All right, take a look at that second one. All right, -2, 2, 6, 10. See what you come up with. And again, like this is n equals 1. And then n equals 2. N equals 3. N equals 4. Got anything back there, Adam Lippy?
Still working on it.
So that's a good phrase. Still working on it. Peyton's up here. He says he got it. We got it.
4n minus 6.
All right, Adam, check it for us. 4n minus 6. Let's see if he's right.
Looks good to me.
Looks good to you?
Yeah.
All right. Now, these two both have common similarities, and like some of the frustration is like, all right, I'm just guessing. There's a way to take the guessing out of it, at least for some of these. If it goes up a common amount, 4, 7, 10, 13, this one goes up how much each time? It goes up 3. That means there's going to be a 3n involved. Okay, that's how it goes up 3 units. This second one goes up how far each time? Goes up 4. That means there's going to be a 4n involved. Well, to make sure you get the first term right, you might have to add or subtract a value. So 4 times 1 is 4. To get -2, you got to subtract 6. So if they go up a common amount, you're going to have like that 3n or that 4n involved. All right, the next one, though, is not exactly the same. Now, this does not go up or go down a common amount. All right, let's take a look at this one. We got to come up with a general expression to make this work. Well, you can almost treat the top as one sequence and the bottom as another one. That's just kind of how I'm going to do that. Well, the only thing that's happening on the top is it's switching signs, right? Okay. All right, now I'm going to do something. Don't write this down yet because it's not entirely right. I said if it alternates signs, you're going to have that -1 to the n power. But why is this not entirely right? Because when n equals 1, is it going to be positive or negative? It's going to be negative, and we want it to be positive. And I'll show you how to fix that here in a second. What can I put in the denominator? What's the only thing it's doing? It's starting at 2, then going to 3, then going to 4, then going to 5. N plus 1. Okay. Now remember, n equals 1 for this first one. So when I plug in 1, I got to get back 1/2. Well, this actually gives me back what? -1/2? Here's what you can do to fix this. If it's gonna alternate signs, but if it alternates in the wrong order, make that an n plus 1. Okay, that'll make that first term positive, the second term negative, third term positive. So depending on how you want it to go, if you want the first one to be negative, you just let it be -1 to the end. If you want the first one to be positive, you can just make it n plus 1 for that one. This denominator, this will go up 2, 3, 4, 5. All right, copy down this one, and I want you to think about it and see what you can come up with. Okay, copy that down, see what you come up with. Now again, n equals 1 gives you 1/2, n equals 2 gives you 4/3, n equals 3 gives us 9/4. First for that one. Plug in 3 would be 6 over 4. On the right track. And what is that one? Nothing yet. Wait, go this one. Wait, nothing. Yeah. Okay. All right. Mia, you got anything?
I have S squared over n plus 1.
So you have a sub n equals n squared over n plus 1. All right. See if that works. See if that makes sense. That should be that. He was in here last period. Okay, no problem. All right, so yes, that works. Did anybody come up? Sometimes you can come up with 2 different cases that work. I don't know about this one. Does anybody else think they have something else that works? All right, so if you just take a look, when you plug in 1 squared is 1. 1 plus 1 is 2, works. 2 squared is 4. 2 plus 1 is 3. 3 squared is 9. You just got to recognize that. They're all a little bit different. Okay, they're all a little bit different for that one. Okay, now, a recursive formula. You do have the definition there. Basically says, requires that one or more of the first few terms of the sequence be specified. So you're told, in this case, what the first term is. The next term, or all other terms, are defined in relation to previously defined terms. So you need to know the first term to get the second term. You need to know the third term to get the fourth term. Okay, that's kind of how this works. All right. Just take a look, see if you can come up, what would be the, any idea what the second term would be? First term is 3. Let's see how let's see. 2, 3, 4, 5. All right. Any idea what the second term is? Okay, from there. Josh, any ideas?
5.
Second term's 5. Okay. What's the third term? Okay, what's the third term? Aaron?
11.
11. Okay. What's the fourth term? Nathan?
Not sure.
You're not sure? It hasn't sunk in yet?
Not yet.
Not yet? All right. Adam?
29.
You gotta work on your, no, I think that's right. 29. Yep. What's the last term? Sorry, hold to Lucas, is it sinking in yet?
83.
83. 3 times 29. Okay, 83. All right, let me go here, and then I'll kind of explain it. Your first term is 3. This basically says to get the second term, you plug in the first term right there. So 3 times 3 is 9. 9 minus 4 is 5. To get the third term, you plug in the second term. The second term was 5. 3 times 5 is 15. Minus 4 is 11. Now you plug in 11. 3 times 11 is 33. Minus 4 is 29. Now you plug in 29. So to get the next term, you take whatever your answer was and plug it into that spot. Now we can go term by term. We know the first term is 3. To get the second term, you actually let n equal 1. Okay, because that becomes a 1 plus 1, which is 2, equals 3 times a sub 1 minus 4. Well, a sub 1 means, so this now becomes a sub 2. The second term is 3 times the first term minus 4. Well, plug in the first term. First term we know is 3. So that's how we get the 5. To get the third term, actually let n equal 2. So the third term is going to be 3 times the second term minus 4. And what was our second term? 5. That's where you get 11. So that's kind of how recursive formula works. You got to know the first term. They tell you that's 3. All right, now we just keep substituting in to get the next term. Okay, for that. So that's 3, 5, 11, 29, and 83. Now this one is not quite as nice, but it's the same principle. Same principle. All right, copy down. Make sure you copy down the formula there. I don't think it's down there. A sub n plus 1. Equals negative 1 to the n power times 3a sub. All right, see if you can come up with the second term and then just stop. And keep it as a fraction. Keep it as a fraction. If it is a fraction. So the first term is a 12. Okay. All right, Tony, do you think you got it?
I got negative 136.
Yeah, negative 136. Okay, I am going to agree with that. That should be your second term. All right, let's take a look here. We know the first term is 12. Make sure you include that. Don't skip over that. To get the second term, you actually let n equal 1. Okay, n equals 1, which means I got a sub 1 plus 1 equals, that has to be a 1 and that has to be a 1. Negative 1 to the first power, 3 times a sub 1, which means my first term. So that means a sub 2, 1 plus 1 is 2. My second term is negative 1 over 3 times 12, which is negative 136. All right, so there's your second term. All right, see what you get for the third term. Plug that in or go through the steps. The third term, n equals 2, then that needs to be squared. That's a sub 2. All right, simplify it though. Simplify it. Luke, let me know what you get.
Who's doing some pretty hard studying on break?
Intensives.
Throwing that against the wall. Luke, you got anything?
we're getting like maybe 1/12, maybe.
It's wrong, but you got some of the right values in there, Josh.
I got 12.
12, positive or negative?
Positive.
Ooh, I got negative. I got negative 12. Cooper, what'd you get?
I got negative 112.
Oh, man. All right, well, we definitely need to go over this one then, because we got too many things. All right, let n equal 2. That means a sub 2 plus 1, which is a sub 3, is equal to negative 1 to the second power over 3 times a sub 2. Negative 1 squared is positive. This is 3 times, all right, what goes in this spot? What's a sub 2? It is negative 136. What's my second term? So that becomes 1 over negative 1/12. There's the 1/12. But 1 divided by negative 1/12 actually becomes 12, negative 12. So that should be negative 12. Okay, that should be negative 12. So I got 12, I got negative 136, I got negative 12. Plug this in, n is 3. That's going to be a negative over 3 times negative 12, which is negative 36. So that's going to actually end up being positive 136. And now go find the next term. Plug in 136 where it goes. Now watch, you got that negative 1 to that power for that. So I got, this would be for the fourth term. All right, so in this case, a sub 1, a sub 2, actually got to use n equals 1. N equals 2, 3, n equals 4. Emma, you got it?
Is it 12?
It is just 12. It is 12. Now, what would happen if we continued with this pattern? The next term would be what?
Negative 136.
Yep, it's just going to go back here. So once I get back to this one, when I plug it in again, I'll get negative 136, negative 12, 136, 12. Okay, but it only asks for the first 5 terms. So you have to list those. All right, this is a recursive formula. This is a recursive formula. Okay, but it's based upon like defining the first couple terms. Okay, all right. Some of you may have seen this. Some of you may not have. 5 with a little exclamation point. It's not a happy 5. Anybody know or seen this before? Josh, you have? You guys have from computer science? No, just from fun. The number file videos you watch in the evening.
Oh, yeah.
Oh, see if I
Tony, know what this is?
I do not.
No? Okay. Yeah. All right. What does this equal? Give me the number. 120. This obviously equals 120. Okay. Yeah. All right. Now flip it over on the back. This is called factorial. For any positive integer, only positive integers, can't do negatives. N factorial, written with the number and the little exclamation point, it's a happy guy. Here's what it's defined as. N factorial means you start at whatever that number is, and then you decrease it by 1, and you multiply them all together until you go down to 1. Okay, you don't go to the negative. So here's what 5 factorial means. 5 factorial means 5 times 4 times 3 times 2 times 1. So that's what it means. And then you multiply them together. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. Yes, there is a button on your calculator. There's probably a button for everything on these calculators. It is under the math menu. If you go over to the fourth one or you go 1 to the left, that's a probability menu. The fourth one down has a little exclamation point. And so I got to put the number in first. So if I hit 5 and I hit second, nope, not second, math, PRB, now the number 4. Okay, 5 factorial, it's it's gonna spit out 120. So spit that out. These numbers get really big really quick. So like if you do 12 factorial, okay, that's 479 million. Okay, so like I said, they get real big real quick. Use a lot in probability and statistics. Special case, 0 factorial equals 1, 0, math, 4 factorial equals 1. Okay, because that doesn't make sense because you're saying, well, how does that work if it's defined as that? We have to define that because it comes up in situations that you need to make it equal 1. All right, let's take a look at a couple cases here. Don't use your calculator because I know you can type it in, it'll just spit out a number that doesn't really help us. Simplify the following. Do not use your calculator. Keep it as a fraction. I do not want any decimals. What is 5 factorial divided by 6 factorial? Well, think about the definition. This is 5 times 4 times 3 times 2 times 1. And this is 6 times 5 times 4 times 2 times 1. All right, cancel. Anything in the denominator can be canceled with anything in the numerator. Okay, so actually everything in the numerator cancels. But don't forget, since we're dealing with multiplication, what's really left in the numerator? A 1. And what's in the denominator? A 6. So 5 factorial divided by 6 factorial is 1/6. 1/6. All right, that second one, 10 factorial divided by 6 factorial times 4 factorial. Now, you cannot combine 6 and 4 to get 10. Those are two separate things. Now, all right, what does 10 factorial mean? It means 10 all the way down to 1 multiplied together. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And this is 6, 5, 4, 3, 2, 1. And then the second one is 4 times 3 times 2 times 1. All right, you want to cancel as many as you can. So I would start with the 6, 5, 4, 3, 2, 1. I would cancel all those first. Okay. This one you could do in more than one way, but I would cancel all those. So now what do I have left? I got 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1. Whoops, that's a 1. You want to cancel again. Now, nothing is a 1-to-1 cancel, but take a look at the bottom. You got a 4 and a 2. What's 4 times 2 equal? 8. You got an 8 on top? Cancel that. So really, they're equivalent. So this 8 cancels with the 4 and the 2. Can I cancel the 3? What can it cancel with on the top? Cancel with the 9. Or reduces. So 3 goes into 9 how many times? 3 times. So here's what I'm left with. I'm left with a 10, a 3, a 7, and on the bottom I just have a 1. Well, what's my final answer then? 10 times 3 times 7. 210. Okay, 210. 210. So you want to be able to simplify it before you start multiplying. Okay, go through those little details. All right, now you probably could have gotten away like here. Once you get a little bit more comfortable, I would do this 10 times 9 times 8 times 7 and just make that 6 factorial. And then that 6 factorial cancel like that. You don't necessarily need to write it all out. Okay, this is the first time through I wanted to do that. But you could just like go ahead and cancel straight off there. All right, number 3 here. All right, you got to know what you're doing. You got to know what you're doing because it's not just constants. So all right, number 3. Okay, how do I represent n plus 1 factorial? using the definitions. It's not a number. Okay, it's not a number. But you got to follow the pattern here. Okay, n factorial means you start with n and then you subtract 1 each time until you get all the way down to 1. Well, I'm starting with n plus 1. So that needs to be the first thing in my multiplication. What's going to be the second term? What do we always do? We always subtract 1. Well, what's n plus 1 minus 1? It's just what? N. N. And then I got to subtract 1 from there. So it's going to be n minus 1. And I'm going to subtract another 1, n minus 2. Now, eventually, I keep doing that until I get down to 3, 2, and 1. I could keep writing n minus 3 and n minus 4, but eventually I guess got to go with 3, 2, 1. Okay, it's going to go all the way down to 1 no matter where it starts at. N always has to be positive. You can't start in a negative number. Okay, so if this is, say, n is 15, 15 plus 1, it'd be 16, 15, 14, 13, all the way down. All right, what would I put on the bottom? Think about that. What would we put on the bottom? Okay. First term would have to be what? So whatever we start with, it would be n minus 1. What would be my second term? What would be my second term? You always do what? We always subtract 1. Well, what's n minus 1 minus another 1? N minus 2. What would be my next term? N minus 3. And then until I get down to 3, 2, and 1. Now you got to take a look. What cancels? What cancels and what's left? Okay, what's going to cancel? Well, basically anything starting with, at the top, with n minus 1. Now, even though there's this n minus 3 down here, there's an n minus 3 in here. It's just not written. And everything cancels. What's the only things that, 2 things are left? N plus 1 times n. Now, a lot of times you will see it left like this, or you can distribute that and get n squared plus n to be your final term. So whatever n is, that's what you're going to be left with, n squared plus n. Okay, for that. All right, so you got to make sure you understand the definition. So whatever you start with, you're going to subtract the 1 all the way. All right, we're not going to finish the rest of that today. We're on page 1003. Finally hit thousands. Don't do those last 3 because they have to do with the ones we haven't gotten to yet.